So if the dimensions of a solid are multiplied by scale factor A, then to get the new surface area would be the original surface area times the scale factor squared. So that's where the A squared is coming from. To find the volume of the new solid, we're going to take the original volume and multiply by the scale factor cubed. All right, so it kind of goes with your units, volumes cubed, surface area squared. So let's try some of these problems. So it says the surface area of a figure is 62. So we're going to keep that for now. That's the original one, or that's the original one, right? So it says if the dimensions are multiplied by 5, what is the new surface area? So the surface area is important because that's telling us we are going to square that scale factor, right? So my scale factor is 5. When we square it, it becomes 25. And so to get my new surface area, we're simply going to multiply 25 times 62, and that gives us a new surface area of 1515 centimeters squared. Looking at the second problem, it says surface area is 736. It says if the dimensions are multiplied. Now, one thing here is it says the dimensions. It doesn't specify whether it's the height, the base, or sorry, the height, the length, the width, the radius, whatever. It just says dimensions. So we apply it to all the dimensions. So it's staying proportional, and that's the reason that we are able to take the scale factor and either square it or cube it, because it's being done to uniformly to the entire shape. And so here it says surface area. So once again, we're going to square it, and that gives me a new of 1 over 16. And so to get our new surface area, we multiply it, and we end up with 46 inches squared. And so for this particular one, we had a reduction. And it's the same thing for all of them. So this one, it says cone A is similar to cone B. So we already know that they're proportional. It says if cone A has a surface area of 1422 and cone B has a surface area of 158, how many times larger is cone A than cone B? So we know that we are going to have kind of like an enlargement, or we're looking for a scale factor greater than 1. And so before we do anything from here, put in the calculator and simplify, right? So if we simplify, that gives us 9. Now, the ratio that we came up with, that's the ratio for the surface areas, right? So it's kind of like, if we think about it this way, we're starting here at the middle, and we got to go back to the original one, right? So to go back to the original one, what undoes a square? And that's a square root. And so here we say that that's going to be 3 times larger. Looking at this last one, it says solid A is similar to solid B. So we already know that they are proportional. So this is the volume of solid A is 21. And the volume of solid B is 4,536. It says how many times smaller is solid A than solid B. So if we're talking about smaller, that means that we need to have some kind of reduction, right? So, but we have to be careful on how we talk about this, and you'll see what I'm talking about. So if we put 21 over 4,536, and then simplify, that's 1 over 216. And since we're starting here and we want to go back to the original one, we're going to raise that to the power of 1/3, find the cube root, right? So cube root of that leaves us with 1 over 6. Now, we can say that it's 1/6 smaller, right? Or it kind of just depends on how you're reading it, right? So we can say it's 1/6 smaller, or 1/6 the size of solid B, or we can also say it is 6 times smaller. It kind of just depends on how you read it, but understand that they both mean the same thing.